In this example, there's a spider sitting right here. It's moving along the x-axis with some constant rate, and what we'd like to do is to relate the speed at which the spider is moving to the rate at which the length of the silk thread is changing. So we're given the spider moves at a constant rate, so its x-coordinate changes at some rate, k. Now, from the geometry here, we can see that in this right-angled triangle, the hypotenuse, which we labeled with length L, will be equal to the sum of the squares of the two sides of that triangle. This is a time-dependent quantity, and so is this. In other words, we should think of this as L as a function of t, which is squared, that equals h squared plus x, which is a function of t, all squared. Again, when we differentiate, we have to use the chain rule. So on this side, taking the derivative with respect to time, we'll get 2 times L multiplied by dl dt. The 2L, of course, comes from the power rule applied to this expression as a function of L, and the chain rule gives us this additional factor. On the other side, h is a constant. It doesn't depend on time. We get no contribution from h. The derivative of this with respect to time, again, we must write down 2x multiplied by dx dt. Now, using the information in the problem, we can plug in here, and this will give us 2x times k. And now we can solve for dl dt. So all in all, we find that dl dt will be equal to 2x divided by 2L times k, and after some cancellation, we get x over L times k.